Hi there, this is Tim Fairfield, Quickstart Technologies. I'm going to do a very quick rundown of how to run an MXR, capture some data using C++ on a Windows system. I've got an example program in a project that I pulled out of the Quickstart IO libraries examples. I'll show you where I got it. So the examples are located here, program files x86. You cannot run them from here because of Windows security in this is 2023. If you try to run this from here, you're going to have linker problems because you won't be able to open some of these up because you're going to have elevated privileges. I do not recommend running it here. Where I ended up sticking mine is in a project folder I put it in my documents code snippet. So my documents is kind of like a Linux home folder where the local user can execute from there. So I've opened up this VCX project, which basically allows you to run things. A few things though, once you open it up under Windows, we'll have the project here. Make sure you click here so that you can see the program files on program.cpp is what we're going to be wanting to look at. If you don't have an instrument, it will run in simulate mode. And if you do have a instrument, then you need to put your resource value here. You get this resource string from IO libraries here. My MXR is at this address. Yours will be different. If you don't know how to do this, if you don't have this set up, what you need to do is go in and add a LAN instrument, enter your address. So put your IP address here. So I can have also a non-high slip. High slip is a very efficient protocol, so I like to use that. But if I put 10.81.216.123 and I do a test visa address, it'll also add this. We'll say okay, and you'll see another entry here show up. So we could use this or this string. I'm going to use the high slip string because it's faster. Another thing now, because we said with simulation is false, if we don't change this variable here, when we go to initialize things, it's going to run in simulate mode, and you don't want that either. We're trying to get running with a real instrument. So if you do this correctly and everything's working, let's just run it again. The other thing I've done here is when we do a startup, in it with options, I set reset to false. I don't want the instrument to reset every time, but you might want to, but I like to just set my instrument and just play around with things. So there's my instrument, and I just lost my window. Let's try to shrink some of this stuff so we can all fit on the same window. So I'm just going to shrink this a little bit because I'm going to show you a few other things here. Yeah, let's just do that. So we see the instrument here and zoom out. I was playing around with the waveform. I've clipped it and I've done some crazy things. Let's go out of fine mode. There we go. So we've got a waveform there from last capture. So if we do a single capture now, we've got a new waveform. Okay, and that's waveforms coming from a PRBS generator. So that's going to change every time. So every time I run, it's going to trigger at a different point. And I'll show you how we can compare the values. So what this program will do is grab a bunch of points. Now I've altered this program a little bit from the default program to have 500 points because the original program says plot the first 300 points or 3 points. I don't want to see 3 points. I want to see a few more. So let's just run it anyway. You can always go play around with that on your own. Let's run this now. It'll build the first time around. Hopefully you won't have build errors. The C example. So it is dumping a bunch of points, which is great. And it's going to wait until I hit a key, but we can see if we look over in the scope, let's do another capture, and I believe it should, the waveform again. Yeah, so it did capture. So it did initiate a new capture each time. So again, this is the guts of getting C++ working. It's not hard to do. You do have to have IO libs. I'm running on a remote computer. My scope is on another part of the network, but if C++ is your choice here, great. I have other examples in Python, and I'll probably do a C# one. So let's look at these points. Now, first of all, I want to compare to what's on the screen. What I got to do, though, is get this data into the middle of the screen. So let me just zoom out a little bit. We're going to use the same data, and I want to line it up because I'm going to plot this. Now, I'm not going to go through. You could use GNU plot or something like that. I'm going to get lazy and just copy it into Excel and just plot it, which I've done before. It just makes it easier. Oh yeah, when I was also plotting these, I changed the number of decimal places from 2 to 9 because otherwise it'll round things, and I didn't want to round that. So again, when you're printing them out, you want to do that. If I was to just another thing here, let's just stop. Oh, I don't want to run it right now. I'll come back to that, but I'll show you what the raw values look like coming back later on. So we'll go in here and I'll just copy that. There we go. So we have this kind of waveform here, and where is it? There. And that is pretty much looking like the waveform there. Yeah, exactly. So we're basically seeing the same waveform as well. So that's just showing that the data is pretty much the same. The other thing I wanted to show you is if we put a breakpoint in there and we run it again, it should stop at the breakpoint. Yeah. So if you want to look at the data. Okay, yeah, I want to look at data. So let's put data as something I want to look at. Yeah, let's look at the data points here. So you can see the accuracy, a bunch of digits here anyway. So that's the resolution or the amount you'll get out of that measurement. And that's it. That's the end. So that's just a quick overview.